Today's lab is based on binary numbers. So let's review the difference between our normal number system, which is decimal or base 10, and binary or base 2. So if we have a number like 23 in base 10, that little 10 means base 10. So the 3 is the ones place, and the 2 is the tens place. So we have 2 tens, or 20, and 3 ones. So 20 and 3 is 23. The way this works is that each number place is based on a power of 10. So the first number place is 10 to the 0. 10 to the 0 is 1, and the number 3 tells us how many of those we have. So we have 3 10 to the 0s, or 3 ones. The 2 is in the 10 to the 1s place. 10 to the 1 is 10, so there's 2 10 to the 1s, or 2 tens. Binary works very similarly, except in base 2 instead of in base 10. So if we have a number like 23 in binary, it looks very different. So in binary, we have to build from base 2. So we have 2 to the 0 is the first place, 2 to the 1 is the second place, 2 squared, 2 to the third, 2 to the fourth. And instead of having 10 numerals, 0 through 9, in binary, we only have a choice of 0 and 1. So the number 23 in base 10 is represented in binary as 1, 0, 1, 1, 1. And that's because each of these powers of 2 can be represented as a number. So 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third power, 2 times 2 times 2 is 8, and times, 2 to the fourth power, 4 2's multiplied together is 16. So each of the ones represents that we have one of those numbers. A 0 represents that we don't have any of those numbers. So we have a 16, we don't have any 8s, we have a 4, and a 2, and a 1. 16 plus 4 is 20, plus 2 plus 1, you should be able to see that that is equal to 23. Now what I'd like you to do is convert each of these numbers into our regular decimal system, base 10, and you should have markers and whiteboards available to do this. Once you're done, go on to the next video and I'll show you the answers and you can check whether you got them right.